Hello, Chi Hang. How are you? Thank you for taking the time to talk to us today. You're probably still catching up with work after your recent trip to the ISSCC. For those that don't know you, could you please tell us about yourself and maybe some of your research interests?
Hello, Homer and viewers. Thank you for having me here. My name is Qian Chen, but you can just call me Ivor for convenience. Currently, I am an associate professor at University of Macau. So actually, our group have been published the first JSCC paper back in 2010, which is also one of most cited paper in IEEE. As you can tell, I have been working in this area more than 10 years. So during my PhD study, my research interest a little bit focused more on the low to moderate resolution, high-speed Nyquist ADC, like such as multi-bit SAR ADC and flash ADC. While later on, after I become a professor, I diversify my topic a little bit, involving some oversampling ADC. Well, but our team still emphasize on wideband, such as continuous time sigma delta ADC and Lloyd shipping PyLISA ADC. Well, in the last couple of years, I extend our group topic to time interleave and time domain ADC. Also, we're working on a digital assist solution, which help the behavioral circuits to have a higher performance to support our high performance ADC. Well, last but not least, we also work on some PVT robustness topic. So make sure our ADC is robust to various working conditions. All right. So rather than just a pure FOM-based ADC, we are working on something which is more practical and redoable. So in total, I have published 18 ICC paper, 22 JSCC paper related to all about this topic. And I hope to share our experience and what we find in the ADC in this short course.
There's a fantastic demand for seats for this cutting edge course. So far, there are 78 participants from 17 countries across four continents and 19 time zones. What are some of the main highlights they can expect from this course?
Okay, so you can see the first thing is our title. Here, our title is, we say extreme, right? So we want to explore the new frontier. And here, what we mean extreme and frontier actually is more than just a single domain. So through this course, you will notice that resolution, speed, power are actually all correlated. So either go for one extreme doesn't actually bring you to the other extreme. All right. So therefore, our exploration will extend to the furthest limit of each. Consider them as a unified bundle together. So here you can see in our course content, this bundle will guide us to explore the interleaver architecture, which we need to have a deep dive. All right. Other than that, we need a very good behavioral circuit, such as an input buffer, reference buffer, to support such an extreme data converter. All right. Then we need our sampler, quantizer, and as well as our clock amplifier. And finally, of course, when we have a good interleaver and behavioral circuit, we also need a very good quantizer architecture. So here we come with our SAR ADC and with a higher performance PyLISA ADC. And finally, we will have a digital assist solution for this extreme ADC with some practical case study and design cases to conclude the course.
Fantastic. Your research work puts large emphasis on robust design, which is greatly welcomed by the semiconductor industry. Can you please share some of your thoughts on this with us?
Yeah, sure. Actually, some of the academia think the robustness is not something they concern. They think this is not the first priority thing they should work on. But actually, that is something different from my point of view. So in my mindset, if we don't consider robustness, we probably propose something hidden. For a good example is at the beginning, we think the SAR ADC is very effective. but you will find that the behavioral circuit of the SAR ADC, such as input buffer and reference buffer, actually may cause a significant amount of power. So actually in our group, when we explore new idea, we also consider robustness so that we can show the actual benefit, the practical, redoable design so that the reader can redo and rebuild very effectively. So that is one of our goals. And also the other is actually our approach to have a robust design is we try to make the circuit work on something which is relatively rather than absolutely. All right. So by that, actually, we can have a very robust design with a relative reference rather than absolute one. When you experience conditional change like PVD, then you can track every circuit by itself. So the other good technique is you try to leverage the cost and fine conversion so that you can actually put emphasis on different resolution on different time. So that also can help the robustness. And finally, as the course content also introduced, you can do some digital assist solution to ensure the circuit actually is robust to some extent.
Thank you so much, Chihang, for your time. We are looking forward to your course in May. Thank you.
Thank you. I'm looking forward to